how about you, all the folks that sitting on the back rows, come closer here. Then we can make a much cozy experience and also nice, like instead of me, looking everyone there behind the, come closer. Trust, it's really worth to, at least you can smell me. I put a good perfume today in myself to give you, so come closer. Yes, come, you're at the right place. Best talk ever. Not really, but I will do my best. So have like 2 more minutes to wait for the last persons. Come closer. No, don't grab this row. Come closer. Here, we have a free spots. Near me. Yay, brave persons. The bravest one that sit on the front row. Yeah. So how are you doing today? How you find the conference? Yeah. Like you're full of excitement, yeah? Yeah. Actually, I really like to start the talk with rising energy. Right? I don't like to speak behind the bars, like become this speaker deck, whatever it's called. So I really need your energy to perform well, because it's kind of like performance, right? So we give them the lecture talk, and we want to entertain you and to give you knowledge, and not just the boring stuff talking about that. Like really make it entertainment. And for this, I need your energy. So I have this energy bar, or I call it applaud bars. So basically, like here, it starts like you're like you now, and then as like we're rising this bar higher and higher, like here you're going crazy, nuts. So like my ultimate goal that other 2 rooms will understand that they're clear not in the correct talk. They need to come here. Okay? So are you ready? Wait. Let's start here. Yeah. Come on. I see you. Go. Woo! Cool. So, 2021. Jesus, what a year it was. Corona is kind of like trying to leave us, all this vaccination, the quarantine is over, things start to open up, you can go to the restaurant. And for us, it was like, hey, we have this new feature is coming out. We have products that product managers that meet with each other and say, oh, we're going to build this amazing feature. It's going to solve X and Y. And then I was part of the mobile team. A mobile product manager comes, hey, this feature looks like perfect match for the mobile, right? We have to build it on the mobile as well, not only for the web. And let's us first build it for the web, figure it out how it works, and then we will build it for the mobile, yeah? Couple months later, these software devs that work on this feature come to us and say, look, hey, mobile team, we have this feature ready for you. We already built it for the Chrome. It's working perfectly. And here is API that you need to use. And you get in this API, you look on it, say, okay, so you call for this get feature request, right? And you get back the name of the WebSocket channel. What? And that actually you need to observe on this WebSocket channel, so you need to open a connection to the server. And then suddenly, after some time, you're going to receive JSON with the payload, and the payload itself is going to be 4 MB? What? Like, how many things can go wrong here? Hi, everyone. My name is Yonatan. I'm doing a lot of things in my life. I'm founder of one of the largest Android community in the world called Android Academy. It's from different chapters. If you want to chat with me about that, come to me after this lecture. Also, I'm part of the Google Developer Expert, and also I'm part of an amazing, crazy company called Monday.com. Who knows what is Monday.com? Yeah, and I'm really sorry if we bother you on the YouTube with our marketing thing. It's not me. But actually, I really like being in this company. I know, sold out, kind of. And this is the story about our journey to the BFF, and we learn what is BFF. So as every story starts with once upon a time, I joined Monday. And Monday is an incredible company that a lot of different huge companies are using our solutions, like Tesla, Apple, Google, Facebook, etc., you name it. And when I joined back in 2019, the web was amazing, amazing product. It worked really well, it had tons of functionality, and was really, really good. And the whole entire R&D department, it was like all engineers were full stack engineers, right? So basically they were writing code in the back end, in the client side, for the front end. Marvelous. Our mobile team was only few engineers, few iOS folks, one Android developer, and me, right? And the whole entire app was written in React Native. It was missing functionality. It worked like a shit. And now a lot of frustrated users with very low score on the Play Store. So we went to the rush of development. We build these tons of the future. We build our own custom recycle view with a lot of stuff. We even created this dashboard of llamas that every llama is the feature that we're missing, and then they're the color of the poop, because if we're missing feature, it's like a kind of poop, and then when we mark it as done, it's become green. A lot of entertainment. We really worked hard, and at the end of the day, we created really astonishing app. We even reinvented kind of recycle view with our own custom implementation that's much more performant than the stock recycle view provided by Android. It was amazing. But we reused our web APIs. And it's basically the same as the picture. It was like mixing Mentos and the cola, and you know what's the result of it going to be. Boom, right? And here are the few examples of what actually. So first, our payloads, our API was very, very slow. If this is the real picture, 17 seconds to get the response. And the size of the response is 8 megabytes. Which user going to wait 20 seconds for the response? No, none. And if it's not enough, we also have this weird situation where we get HTML as a response with the 500, and we can't really figure out why it's happening. And also we have our own status codes, who knows what is a 580? I didn't know either. It's for me, someone invented this new status code in our web server. And of course, we had tons of breaking changes. We had this contract, for example, this simple JSON that you translated to the data class in the Kotlin, right? So you very data type strict, right? It's not dynamic. But then actually someone accidentally changed our ID become each check become from the Boolean to the 1, because this is how it's saved in SQL. There's no true false. Then someone exposes it, and then you get illegal state exception. Then our ID become from the integer actually to the long number, and also kind of we forgot about it. Not we, our backend team, our full stack engineers, and of course all this famous null pointer exception that something become null, and we're narrated. And when we start to mention that to our other engineers, full stack engineers that actually were building these features, they say, oh, what's the problem? Let's use API versioning. And you know how API versioning was looking for us? This is not API versioning. This is not how you do it in the mobile. So, all this is kind of like a joke, but this is the reality for a lot of the companies. And so what we were trying to do is we have this amazing monolith API, 2019, the company very successful, by the way, business-wise, running forward, crazy, really amazing company to work with. And we had amazing application in the Chrome working perfectly. Then we have this desktop app and using the same API, and then we connected to iOS and Android, and all of them using the same API. So basically one API to rule them all. But then actually we even start to grow. So we had this third-party API that we start to connect to utilize our own API monolith. And then we have this own automation, or it's a predecessor of AI that also was using our same API that was built for different purposes. And on top of the iceberg, we also expose it to external developers to build apps on top of Monday.com. And clearly, it didn't work for any of them. You need to do something alternate that's specific for the specific client. So we came to the full stack engineer, said, hey, look, it's not working for us. Our life is hell. So say, hey, we are full stack engineers. We are building API for ourselves, for our feature. Why you, mobile team, can do the same, right? Who said that you need to only know about Android or about iOS? And it's kind of right. But when you look at it, every single client, there is a specific logic that you need to implement, right? For Android, it's something different. For Chrome, it's something else. For third-party APIs, it's a completely different story. And then we start to have this in our endpoint, something like popping up this alternate logic, like is mobile app, is it automation, or is it CRM system? And adding to that is like our monolith was written in Ruby. Who likes Ruby? Right? No, really. Guys, I'm removing my head from you, for you, because you have really strong guts. For me, it was very frustrating to write something in Ruby. I like Kotlin. Kotlin is an amazing language. I know it. I can use it. I know how, bits and bytes, what I can do, what I can't. And, basically, for me, the life writing endpoint in Ruby, in monolith, with all this deployment was a hell. And the last drop was amazing feature called My Work. It's like real story, right? So on the web, this is what they built, amazingly worked well. It was very fast adopted. And say, hey, this is the very mobile-ish feature, right? To have this one centralized place of all tasks that you need to finish. So, we start to work on this feature and then figure out that actually mobile need only the fraction, really small fraction of everything that this endpoint was returning to the web. And then there is additional logic that we need to write in every single client. So there's additional logic on the web, in Android and iOS, in order to build this list of all tasks that user need to finish. And then also, of course, the endpoint itself was very, very slow. In a way, it was built like with this channel that you need to observe and wait until the data will return, because sometimes it was over the 1 minute, right? So you can't really, you get timeout when you're waiting in the active connection. And why is everything I tell you so much troubling? From the perspective of DevX, okay, but like, why it's like really so matter? So here's me to give you a full picture of that. How many Android version was active for Monday.com in last 30 days? Guess the number. 10. Okay, who else? 7, 20, 50, 144. Okay, different versions were active in the last 30 days. What's the oldest version that was active in the last 30 days? When it was developed, released? 2 years ago? So very close, like 3 years ago, this is the version that was used recently. Think how crazy it is. Like all the skeletons that you developed and put in the version, it's like maybe going to be deprecated in 3-4 years from now. So like the things that you write, they will live with you forever. So clearly, we can do better than that. And this is how we started the whole journey of BFF. So we called it best friend for frontend, but in reality, it's backend for frontend. So in a nutshell, it's someone that translating the data from one stream to another one. And to give you the full picture why we go with direction, so we wanted something that we can own. We as a mobile team can really work on it, iterate over it, and do something about it, right? So clearly, it's like become kind of like middleware, where we as a mobile team have responsibility of the entire cycle, how this thing is working, deploying, how it's returning the data, and we can make the decisions based on our needs for our application, either Android or iOS. So how to build the BFF? So which tech stack we're going to choose? Obvious question, right? So who think we need to choose the Kotlin? Okay. And probably you think about what? Cater, right? Yeah, or Java? Spring? Yeah? Cool. So totally wrong. First, the thing is actually to understand what exactly you want to build, like what's required for your own application, right? Oh, no. no. It's like very weird situation. Someone comes to you like with this big camera and thank you. So the tech requirement is like basically to understand what exactly you need to build, right? What exactly you need required for your app. And one thing is, first of all, you want to minimize the impact of having this man in the middle, not man in the middle, like backend, additional server that's going to process a request. So like the lowest latency possible. Then, of course, offline support, right? So it's something like unique to the mobile. We have these offline devices that become that they need to sync time on the time. So maybe you need to build these APIs that can provide, from some certain timestamp, provide all data to sync, right? Data usage, like, you need to return only the data that was requested, not more than that. GraphQL. Then, of course, like push notification integrations, like it's very, very, very unique to the mobile, and to have this integration is absolutely must. It's supported. Image and media handling. Our mobile devices, this is what they're doing, and they're showing pictures of the cats, right? So you need probably some sort of like optimization that you can run on your BFF and to serve for Android, for iOS, and format that they're expecting. Real-time data, like WebSocket support, and of course, analytics and monitoring. This is the requirement, less or more. For example, that was relevant for us. And then once you understand this requirement, it's basically about choosing the stack. So first of all, I think the most important thing is to choose what you like. It's kind of like obvious, but something that your team will have a fun to build, right, and not to suffer on the way. The second thing is type safety, right? Our iOS and Android live in the type-strict world. So having backend BFF written in the type safety manner is something that really can help you to manage all this cycle. The third thing is actually third and fourth, and put them together, is the development speed and team expertise, right? So Rust, who knows about Rust? Few. So it's a new kid on the block, right? Very performance server, like you can write amazing stuff, like very fast, etc., etc. But probably your team don't have any experience about it, any expertise, and the velocity of developing will be really, really, really slow, right? So maybe it's not a good choice. And of course, community support and ecosystem. So for example, we all said Kotlin, and for example, Ktor is one of the options. If we compare it for the Node.js, which is another alternative to this, it's like, the ecosystem is clearly not in favor of Ktor, but for the Node.js, right? Amazing amount of the libraries, open source things, and the number of Stack Overflow questions, 500,000 versus 1,000. Clearly, the difference. And also, like, it's suitable for a purpose. Like, for example, Go, very performant, but probably for the BFF, it's going to be the overkill, right? You were going to kill, it's like to killing the fly with a nuclear bomb. So for us, we choose Node.js with Express using TypeScript for different reasons. First of all, it's very similar to Kotlin. All this async, await, syntax, you can change stuff, right? It's very easy to start. There's a lot of getting started from zero to hero. It's typed, it's aligned with all other microservices. So if we need help from other folks in the company, we can get on board. It's very popular, like amount of open source libraries for this, like for everything that you want, it's there, it's in the internet. And one thing that especially I think is the most suitable for the BFF is non-blocking I/O. Who knows what is the non-blocking I/O? Cool. So for that, I prepared the slide because I just think it's cool, but not in this way. It's like, this is very boring. So I kind of like reworked. So think about that you have a lot of requests that come into your server, right? So it's Node.js is a single-threaded. So like it's one single process that taking care of all requests that coming in. And it's working very, very, very efficiently. Why? So basically, it's request is arriving. And what is happening in BFF? Usually, we're going to other microservices or to monolith to obtain the data, right? So we make this request. And instead of waiting till we'll get the data back, it's actually putting the callback in its kind of queue and actually going to serve another request. So basically, don't wait for anything. So all I/O, like going to the database, to the external resources, or like to file, etc., they're not blocking the current rest. They just like continue forward. So our server become very, very efficient. And actually, it's like this is what we need for the BFF most of the time, to process the data from our microservices, to do some manipulation, and return it back to the client. So once we have it, our tech stack, now we need to define the APIs. So my suggestion, actually, this is what we did. Start with one single endpoint, or one single feature that you can try, you can iterate, you can understand what has worked for you, what doesn't, and move forward. I would say like keep it simple as possible. Start with the REST. REST is like one of the ways to build the API. It's like very simple. And move forward. Just move forward and evaluate for yourself what works, what doesn't. When you design API, don't design it from the perspective of how your schema in the database looks like. Design it from this perspective what client need. So for example, if we take this car metaphor, so every client needs something different, right? So don't serve separately wheels, color, I don't know, wheels, chairs, etc. Right? So serve the car already and do all this manipulation specific for the client. Take into account that we want minimize impact on our customers in terms of performance, like low latency and optimize data as much as possible. And in this point, actually, I'm moving it to the GraphQL. I really love, and I think this is the best solution for the mobile clients that we really need to go into it. And I'll show you example. So basically, GraphQL is a way to communicate between client and the server. And the thing is that in the GraphQL, you, as a client, control how much the data you want to receive. And to build it is very, very simple. I will show you a little bit of code. So I think we defined two types of in our system. Like, I'm really a fan of Marvel. So we defined like character and comic. And the character we have ID, name, description, and the comic that it belongs, comics that it belong to this character. And then actually we have type of the comics that actually have ID, title, issue number, and also reference to the characters that in these comics. And then actually we exposing our what we can do with this GraphQL. So we call it query. And then we can query character by ID. We can query all characters that we have, or comic specific by ID that return the comic. And in Android, it's like very easy. You define this query, get the name, get character, and then you basically describe what you want to receive. So for example, here we want to get the character by ID. We want to get the name, the description of it, and also the comics that it belong with the title and issue number. Right? So we don't need to get all the data. Basically, we control it from the Android side. And as a response, we got back JSON with all the information that we received. For example, here it's iron name. And in order to run it, so for example, you can use Apollo client. Very simple, very similar to retrofit. You basically build a client with a URL. You create a query, so you get this get character query with ID, and you call Apollo client with a query with a wait, and you get response back, and you can do whatever without it. So very easy to use, very easy to build, huge amount of improvement and actually flexibility for the clients. And then it's reaching the point when we're actually, okay, so we have this API on our BFF side. Now we need to kind of like to understand what we need to take from the monolith, like how to say goodbye. So first thing is like there's amazing tool. I think it's one of the best tool, is pen and paper. Take pen and paper and actually to plan what exactly you need from the monolith of other microservices. Then define this endpoints and what's the changes you need to do. And then at the beginning, just like bypass, like to create one-to-one reference from the monolith in your BFF and make it work and see what's the impact like in numbers. So there's shouldn't be any impact like in milliseconds, maybe only that impact on the performance. And then once you get it, now start to rework. And the special thing, don't forget, like before that, all errors that was happening on monolith, they were propagated to the client. Once you build this BFF, basically you need to take care of these errors, expose them as well. Because by default, actually, your BFF will get an error. If it's not translated to the correlated error by itself, you will send 500 to the user, and that's very frustrating thing to get 500 that don't understand what's happening. And then actually we're reaching fifth point is to plan versioning. So there's a lot of different strategy how you build versioning for your API. One of them is actually to have this in the params. So you're passing version number 2, for example, equal to. It's very simple to implement, but it's become mess if you have a lot of params, right? Another option is to pass the version in the header. But the downside of it is hard to debug. When you look on the logs, you don't understand which exactly version was sent by this client and if there is something different happening. Very commonly used, the one is actually to have it in the path. So you put as like V2, V3, and V4. The downside of that is create a lot of duplication. So your routes will going to look like a mess a little bit. And another thing, the last one is having this negotiation for the versioning that's accepted. As I mentioned, we're using GraphQL. So GraphQL is only one endpoint that accepts all queries that are requested by the client. So which version we choose in monday.com? If it's only one endpoint? Which? Last. So actually, we choose the header, right? Because it's only one endpoint, one path, but the schema is like types are changed, etc., etc. So the only way to pass it in the header, where we're passing the version that we know we want from the client side. And then actually, once you understand all this, now it's time to build it actually. And then here's like you build it for the performance and for the scale. You need to understand that. That actually, you're not allowed to do anything unless you improve the latency. And actually, you can improve it in various ways. So one, for example, you can take, like for example, your client were making 3 API calls to get the data for a specific feature, right? And you can combine them actually in your BFF. For example, here I'm combining 3 different endpoints from the 3 different services into one to expose it. So basically, our Android app will do, instead of 3 calls, going to do the 1 call, and then BFF going to do these 3 calls. Why it's much better than before? Anyone knows? Why to do 3 calls in the BFF is much more performant than to do 3 calls from the Android device? Exactly. Yeah, exactly. So BFF sitting in the same data center, right? So the communication with the monolith is much faster than Android device that's, like, for example, that from the South America trying to reach our data center that's sitting in the North America, right? So to build this in the BFF will be the much more faster for the Android device than having in Android device by itself. Or from the different direction. For example, you have one endpoint that's very, very slow because it brings a lot of data. You can minimize, like instead of like 10 seconds that bring whole heroes, for example, you can build it 3 endpoints that each one of them will bring small portion of the data from the monolith and then combine them in the BFF and exposing to the Android. So huge amount of improvement they can make. And also, like it's allow you, because this BFF is a standalone instance, you can scale it much more than the scaling monolith, which is much more costly because it's like, usually the monolith is much bulky, they require a lot of resources. To scale BFF, which don't have any data layer, and we will talk about it a little bit later, is much cheaper, is much more easy to do than scaling any other things. And of course, when you're speaking about low latency, amount of data that you're passing is also like affect the latency. So I already mentioned a couple times, use GraphQL, a great thing to minimize the amount of data that's passing. And then we're reaching the point of caching. So caching is a great thing. I mentioned 2 things. E-tag, who knows what is the E-tag? Great. So for those who don't know, it's basically, it's a hash, it's a digital signature of the content that was sent to the client, to the Android, right? So what's happening is Android received the response, and then actually it's saving this response and to show to the user, and also it's saving this digital signature called e-tag. And then next time when the Android needs to refresh the data, it's basically going to send this request for the new data with this e-tag, and the server will check if the e-tag, the last e-tag that I have for the data, is the same the one that Android sent. Then it's going to return 304, not modify, so basically you don't need to pay the price of transferring the data. You basically just return, nothing changed, use the same data as before, or actually returning 200 with the new updated data. And we will see the example of that. And another thing is distributed cache. And when I'm saying distributed caching, usually like we're referring to the Redis. It's very, very popular. Basically, it's key value in-memory database. And by the way, it can be persisted, but it's very, very, very fast. Very, very fast. Basically, how it works, you call for your BFF. BFF can obtain the data from this Redis by just passing the key. Key can be name of the data or name the data with account ID or user ID and returning back. And there is a lot of different strategy how you invalidate this cache in Redis. Why call it distributed cache? Why we need the distributed cache in BFF? and not just the cache? Any guesses? I mentioned like hint, scale, right? So, yeah? What? Exactly. Because we have a lot of friends, right? Because a lot of instances of the friends, then we need to this distributed cache. So when the Android making the same request, it's not guaranteed that he will reach the same instance of the BFF. It can be multiple instances, and we want this cache to be across all the instances of the BFF. And the last thing that when you build it, you need to take into account is logs and monitoring. So who used here Firebase? You know, yeah, very popular tool. We're using for the logs, for the monitoring, for the dashboard performance, very, very good. But it's not enough. When you're speaking about huge scale, it's really, really not enough. So like our recommendation, we can build inside our BFF to report. So instead of reporting direct for the Firebase, you can report it to our BFF, and BFF just bypassing it to any tool that you choose. For example, Datadog, really amazing tool, highly recommended for any performance metrics, and the Core Logic for the logs. Like really, really, really highly recommended. And we almost reached the end. So what not to do in the BFF? So first of all, don't put any business logic in BFF. It's not the purpose of BFF. Basically, everything that's not related to the data manipulation and flow optimization should be in service, in monolith, etc. It's not the place to do this business logic. Don't duplicate any other services, microservices they have. If you're probably doing that, it's a good sign that maybe you need to build this library that you can share across different services. Don't turn your BFF into data storage. It's not the goal. If you will do it, you will hurt your velocity, you will hurt how you can scale, the cost of scale, etc., etc. And don't perform any heavy computation, otherwise you will hurt the performance of your BFF. Of course, don't compromise on any security. You know, now when you build this BFF, actually you become the front guy for everything that's coming to the system. So instead of all this security was built on top of monolith, now it's your responsibility to do the same, or at least be aware of the security risks. And of course, don't build one BFF to fit all the clients. All clients are different, and we already saw in the monolith. So how hard is to create BFF like code? And I will show you like 3 slides. This is all the code that you need to build one single endpoint. I will use it Node.js with the Express and the TypeScript. So basically, this is how you build the server. You call it for the Express with the app, with the port you want to run. You grab instance of the Redis. That's it. You have a Redis. You create this interface of, for example, Marvel Hero, right? So have ID, name, and description. And also, I created schema validation, like schema to validate the JSON that I will receive from the monolith to validate that nothing is breaks. And then we build kind of like middlewares that we will chain after another on our request to validate or do different stuff. So for example, here's a caching middleware. We take the cache key, call it Marvel Heroes, and we just like call get, and we get the JSON from. That's it. This is the whole distributed caching. That it's very simple to use, very simple to build. And then if we have this cache data, we store JSON on our response. We can, modify this response. Like one of the great things of Node.js, you can do whatever you like. It's like very, very like kind of like Wild West, but it's very flexible in terms of what you can build. And I personally really like it. So here, for example, I use a response in object to put my cache data inside of it and propagate to other middlewares. Then we have this eTag validation middleware, right? So we spoke about the distributed cache. Now we talk about eTag. So basically, we have a cache. Now we can compare eTag from the request and eTag that we generate based on the cache that we have. And if they're matched, we send back 304. If not, we set the new eTag, and we continue further. What's the further? We need to check the schema, that actually the data that we get, we validate the schema. It's from what we're expecting to get. And if there is no error, then we proceed. And then everything together, stitching, like we expose this one endpoint called Marvel Heroes. We apply middlewares for caching, for the eTag, and then our function, the final function, actually getting request and response. So we take from the response the cache, turn it to the JSON, and that's it. If there is no cache, so we're going to our monolith, so we're going and fetching from our microservice Marvel Heroes. We take the JSON data of it, we pass it to the schema validation just to validate the JSON that we get, it's in our schema that we're expecting, and we save it in our Redis, simple as that, in our distributed cache, just as a JSON, Redis set. We calculated new E tag, we put it in our header, and we send it back to the client, to the Android. And then we run our server. That's it. This is the whole thing that you need to build in BFF. And if it's complicated, then you know what you can use? ChatGPT. Yeah, actually, I generated this code using ChatGPT because we are developers are lazy. Cool. So back to us, back to my work. This is the feature that we built using. It was the first feature that we built in BFF. And we didn't put any logic in Android. Basically, the only logic that was in Android is to get the JSON and just the draw UI. That's it. No any manipulation, nothing. And when a couple months after that, after the adoption, a product manager came to us and said, look, we need to change how we group by our tasks. So right now, it's based on the dates, and we need to group them based on the status. And like, no problem. 5 minutes, I can do it on the BFF, and that's it. It was very easy, and clearly, it saved us a lot of time. So where are we now in Monday.com? Oh, so we're already 2 years in production. We're already 2 years in the production, working like really flawless. We think we migrated more than 70% of all endpoints, and of course, any new feature is written only in the BFF, only by us. We even introduced our own analytics tool to grab the data and actually to minimize all the cost and the risks. We have our own tooling to measure performance that's dedicated on the mobile team that we choose for us. Think how crazy. We don't need to stick with a monolith and their choice of the performance monitoring tooling, but we can choose for us what is performing for our mobile team. And most important, we had 0 production incidents in 2023. Everything working really, really good. And really pleasant with our choice. So, wow, we're almost done. And I'm the only one that's standing before you and lunch, right? So let's keep you here. I know I've blown your mind with a lot of different terminologies, et cetera, but the reason why I'm doing, one of the big reasons, first, I really think that we, as the mobile engineers, Android or iOS or Flutter, we really need to start to look on other worlds, and this is what will make us better engineers and make better choices for tech solutions, architecture. Being mobile engineer is just one step of the evolution. There is a lot of different aspects that required, and BFF, I think it's one of the things, one of this opportunity where we, as Android engineers, can step and being in the shoes of backend engineers, understand all these concepts of Kubernetes, scale, monitoring, performance, optimization, et cetera, et cetera. So thank you all. I hope you really enjoyed.